What's up, Bob? It's the holidays. Boom, 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 boom. All right, stop music. What is this noise? What are you showing me here, dude? What noise? What's going on here? Channel. There we go. Oh. Oh yes. Yeah, a little trick substitution. Oh, this is fun. Wow.
Hello.
What's up, Ethan? How's it going, dude?
I'm going okay.
Okay. Yeah. Hello, gamers. Hello, noise. You have school today, Ethan? Are you done with school, right?
Yeah.
Nice.
That's dope.
I have a couple more students that still have school this week. I think their last final exams are tomorrow and Wednesday. Yeah, that's what it is. This guy's question. Whose question was this, Noise? Whose question was this? I saw you posted a bunch in here. You posted a lot of cool things. Oh no, Bob, you got 7 out of 15 for the what was it, for the pyramid question? No, Bob. Oh, the last guy to post. Who's the last guy to post? Oh, Josue. Oh yes, okay. Yeah, that's a good question, Josue. Oh my god, yeah. What was all this? I gotta go through this with Bob at some point. But yeah. All right, cool. Oh, we got a bunch of questions today. Okay, cool. All right, here. Let's kick it off. Let's kick off the stream. All right. Welcome everyone to Office Hours. My name is Dr. Golden's Actual Education. Stream helps you out. Math homework, science homework, all sorts of fun stuff. We got a lot of cool questions. I think we're gonna get a bunch today because it's it's basically the end of the year. No one's really in school, but I love it. Yeah.
That's cool.
What's up, dude? What's up, Ethan?
It's like day one already of my 3 weeks, and I'm already bored.
Oh yeah, I understand that, dude. Yeah.
Like practical. I already want to do work.
You want to do some work?
So, yeah, like any kind of work, like in my class, because I still want to be in shape for exams next
That's
year.
good.
Like,
Yeah, that's kind of weird that you have a break and then you take exams, because I feel like you would just forget everything.
yes, like I just wanted to take it this year or something.
Yeah, that's whack. So usually in the U.S., like we take our exams before the break, then we go on break, and then the next year starts and you start new stuff. Not this. You just don't go to school for 3 weeks and then surprise, bitch, we got final exams. Like that's terrible.
It's just a rough year.
Yeah, it is rough. That is
So,
absolutely rough.
like, do you think you could give me physics work or
Yeah, of course. I can give you tons of physics stuff.
think-
Yeah, we can always give you physics stuff.
like? What about noise? Like, I really
Noise
don't
is
think
kind of busy
it's
these
cool.
days. Noise has a job and like a pseudo girlfriend right now, so I'm not sure he's
No, I
necessarily
don't.
around to
I'm
teach you
not sure.
physics. But he says he can teach you integration.
What's integration?
Integration's calculus.
Okay, then.
Yeah, that's good stuff. Okay, let me run through some of the questions we have, just so we have time and stuff. We already did this with you, Ethan. But let's see. Noise. Were you asking a physics question here, Noise? Is this a physics question? A coil is rotated at a frequency f in a uniform electromagnetic field. The magnetic flux linking the coil is a maximum at time t1, and the EMF is a maximum at t2. Okay, what is the smallest value of t1 minus t2? Oh, okay. Let me think. The EMF is a maximum at time t2. Oh, because this has to do with sine and cosine, right? Doesn't it? Noise, right? Because what is it? Phi b is equal to b times a times, what is that? It's cosine of theta, right? And then so EMF is negative d phi b dt. So that's going to be, in this case, negative ba sine theta. Cool. D theta dt, of course. Okay. And so these get offset, I guess, is what it does. Yeah. It's interesting. Because, for instance, when this is maximum, right, that means that theta is going to need to equal 0, right, in order for cosine of something to be the max. Cool. And then, yeah, here we say theta, right, is equal to omega t, right? The angle is a function of the angular frequency times the time, where this is really equal to 2 pi f times t, right? You also learned this in physics, right? Omega is equal to 2 pi f. Angular frequency is equal to 2 pi times, I guess, what we call it, linear frequency or something. So, cool. This is going to be 2 pi f t. And so, right, that'll equal 0 when t equals 0. Cool. And then it's a maximum at time t2. Okay, so if this is going to be a maximum here at time t, let's just say t equals 0, then this will be a max, the shortest amount of time after that can be, right, is a quarter of a revolution. That's when theta is equal to 90 degrees, or let's just say pi over 2. So now I need 2 pi f t to equal pi over 2, right? Okay. So that tells me that t is going to equal to, what's that? We divide this over, right? That's pi over 2 times 2 pi times f. Okay, cool. Pi's cancel out. Love that. So that's pi over 4f.
Wait, that's a goal?
What's up, dude?
You were saying something about
Oh,
omega
there's no
is
pi,
equal to
actually.
2 pi and something?
Yeah, omega is equal to 2 pi f. Yeah, this has to do with rotational motion, I guess. It's physics. You haven't done this yet. You haven't done omega. I don't think you've done omega stuff yet.
No, I haven't even heard of that.
It's
See,
okay. It's new to you.
No, I actually heard of him giving me a formula that I kind of saw. Like,
Okay.
you see that little weird W there?
What weird W?
Like, there was, I think I just saw a W there.
Oh, this one right here? This W?
Yeah.
Yeah,
Oh,
omega.
see? Same one. Hold on. I can remember I saw that in the vectors or love or something. Vectors turn into common area, right? He had it right here for something called simple harmonic motion.
Yeah, simple harmonic
or
motion.
or equation for displacement, which is like this is equal to a cosine wt. That's what I
Yes.
see there.
Yes. Yeah, it has to do with that. That's kind of rotational motion. Harmonic motion, simple harmonic motion is also rotational motion, if you think about it in terms of phase angle. Yeah. Is this correct, Noise, by the way? Is it 1 over 4f? I'm pretty sure that's what this is. That's what I get here. Because t the initial t was just equal to 0. So then this t is 1 over 4f. So the difference should be 1 over 4f. It's kind of a cool question. What's up, Teacup? Are you feeling better, Teacup? I know you were sick recently. Still sick. Uh-oh. Everyone's getting sick. Yeah, I don't know. Yeah, check noise. I'm curious.
That ain't me.
That ain't me either. Yet. I hope I don't get sick. I gotta go see my parents in like a couple days. If I'm sick, that's gonna be bad. But yes, Ethan, what you've seen, for instance, in simple harmonic motion, you've seen this. You've sent x is equal to like a cosine omega t, right? And then d.
Wait, is omega really just W?
Yeah, it's just w. It's just fancy w. That's all it is.
What?
So this is AW, negative AW sine omega t. And then this one is, I don't know, if you want.
Wait, omega t is like a
Omega is just a variable, and this becomes what is this, negative a omega squared cosine omega t. Yeah, this is velocity. This is acceleration. This is where this all comes from. I'm pretty sure that's right. Noise. You let me know. Cool question though. Let me see. What else do we have? Bob's one. Yeah, here. Let's let me go through this one. Well, let's see. Who was first? Was Josue or Bob first? Oh, Josue was technically first. Okay, here. Let me do Josue's first. Real quick. Well, real quick. Because I guess Josue, Noise did yours. Noise did his earlier one. So this is correct, Josue, by the way. This is the correct way to do this question you asked. It's actually a cool thing. It's using U sub, I guess, is what you're doing, and then realizing that cosine squared can also be written in terms of what's called a double angle identity. It's a very cool one. Noise says, I can't even find where I got the question from. Yeah, I'm pretty sure that's correct. Anyways, that one's not too bad. But let me see your other one, which was this. Absolute values. Oh man. Okay. When we get questions like these, we need to figure out where this thing is negative and where this thing is positive, and we have to split the integral is what we have to do. You drew a graph on Desmos. Did you draw a graph on Desmos for this one? That'd be pretty cool. You have a question on it? What do you have a question on, Josue? Let me know. Or did you have a question? Sorry, did you have a question on Noise's solution from this one? Here, you can also yeah, here. If you have a mic, you can come speak if you want. It's probably faster. You can also chat if you just want to chat. What's up, Josue?
Hello?
What's going on?
Oh, so on that one, you just use a U substitution, right? So you got to figure out that you can like put the sign, and then you can use the formula, which is like sine squared plus cosine squared equals 1, right?
Exactly. Yeah, maybe he didn't explain that too. Yeah, but that's where that comes from. Yeah.
Oh, so you gotta like get creative in a way.
Yes. Yeah, some of these calculus questions, yeah, you do have to be kind of, again, you wouldn't really, if you saw this for the first time and you had never seen this question, I doubt you'd be able to do it. Because if you haven't seen the trick, you're not going to be able to get it. And this is why, like, you end up doing these things on homework and whatnot, because you start to learn, okay, anytime I see a square root of 1 minus something squared, I'm probably going to use sine, because 1 minus sine squared gets me cosine squared. Yeah.
Oh, okay.
So that's why this, this became cosine of u, and then you get cosine squared of u, which then again you have to recognize another clever thing, which is that cosine squared can also be written in terms of the double angle cosine of 2 theta. I don't know if there's another way to do this. I think this is kind of the only way to do it. Were you in like was this like your trig version of the class or something?
Oh yeah.
Yeah, this is, so yeah, and Noise brings up another good point. So where these are really going to come up with is when you start doing the hyperbolic trig substitution. Let me get some pictures of them. Yeah, it's our trig substitution integrals. Where are they? Show me. No, I don't want these. Where's some nicer? Okay, but yeah, this is kind of the other thing that happens. So, anytime you start seeing something in an integral here, Jose, that like you see like 1 over like the square root of something squared minus x squared, you end up doing this substitution, which is you're going to say, oh, I'm going to let x be a sine of u. Or in this case, if they're adding, you say this is a tangent of u. Or if it's the flip, if it's x squared minus a squared on the bottom, then you use a secant of u. And those end up doing similar things. So in this case, right, when you have 1 minus sine squared, that's going to get you to cosine squared, which then you're square rooting, and it's just 1 over cosine, which is nice. In this case, with the a squared plus x squared, that's because 1 plus tangent of squared is equal to secant squared. So this whole thing ends up becoming the square root of secant squared, which is then just secant. And then by the same matter here, when they're flipped, this is because secant squared minus 1 is equal to tangent squared. And so this will end up becoming the square root of tangent. So they're patterns that you want to get used to noticing. Whenever you have square roots and you have these sort of things happening, you want to end up using one of the appropriate trig functions to try to get a clever, identity out of it. Yeah, it's just there's just patterns to it. Sorry, what were you gonna say?
Yeah. Okay. So that's like the trig substitution kind of.
Yeah, that's trig substitution. I'm trying to see what was the hyperbolic one. Hyperbolic integrals. I remember it was. Where were there some nicer ones? Well, I guess yeah. You can also use sinh and cosh, and all these, but I mean these like suck. You don't really want to do these. Yeah. These are the other ones you end up using, the hyperbolic functions, which are similar. But again, it's hopefully you get some sort of table. You don't have to memorize these for your exams and whatnot.
Oh yeah, we get a cheat sheet.
Oh good, then yeah, you can just write this shit down. There are ways to derive this like on the fly, but it kind of sucks. Yeah. Yeah, here we go. There's all sorts of nice like tables here and whatnot. I'm sure if you just Googled like, there we go. Yeah, this is like these are the hyperbolic functions. So similar to how I showed you, you could do u sub with regular trig functions. You can also skip all that nonsense and just go straight to the hyperbolic trig functions or inverse hyperbolic trig functions, and that's just what they become.
Does it make it easier to do it that way?
Yeah, I mean, because, if you do the u substitution way, you end up having to do a little bit more work. I think you end up having to do, like, double u sub, like, basically. It's kind of a pain in the ass. But in this case, if you recognize that one of these patterns is here, especially this one, when this one pops up a lot, where it's, like, 1 over, and then it's, like, u square root of a squared minus u squared, this one, you just want to write this as hyperbolic secant. It's a lot simpler than if you do trig substitution. You end up having to do it like 2 or 3 times. Similar to what happened in, what was it, in this question, right? We did do a trig sub, right? And then we also had to do a trig identity as well. And then you had to do like 2 separate integrals, right? And it was kind of eh. But in the case, let's say this was in the bottom and it was a fraction, it was 1 over the square root of 1 minus x squared. You can just instantly say that like, oh, cool, that is, this one, or where is it? This one, I guess, yeah, or one of these, and it's the hyperbolic one. Yeah, yeah, they're good ones to know. Noise says, ask Symbolab to do this one. What is it? X equals 2 cosh of u. What do you want me to do with x equals 2 cosh of u? What's up, Falcon? Yeah, okay. And then, all right, so then let's see. This was the one you were asking about, though, right? This one right here?
Yeah.
Yeah, so, yeah. Anytime you start seeing this absolute value in integrals, we have to end up breaking this integral up into the places where it's negative and the places where it's positive. Because you know from regular integration, right? If I integrate something like this, right, this area ends up canceling out this area as we integrate right from left to right. But if I do the absolute let's say this is f of x, right? But if I want to integrate, for instance, the absolute value of f of x, okay, now these areas will add. Okay? So what we have to do is we have to break up our function such that we're going to do one integral from here to here as regular as it is. But then from here to here, I'm going to do the negative of it to flip it up. And so that I get only positive area from it. Does that make sense? It's okay if it doesn't. Yeah. I'll find a way for it to make sense. Yeah. That's what I always say. You know, most teachers, right? They'll give you something. They'll be like, "Everyone get it?" And no one says shit, and then the teacher just keeps going. But then people are just confused. So, like, please, if anything doesn't make sense, or I'm going too fast, or if I drank too much coffee today, like, let me know, and I'll chill out, and I'll find a way for it to make sense to you. Anyways, okay. So what you have to do here, right, is figure out where this function would be negative, right? So I want to know where is 3 square root of x minus 6 going to be less than 0? Like, when does that happen? And we know it's only going from 0 to 16. So sometimes if I don't really know how to do this, like, right off the bat, I'm just going to plug in numbers and see what happens, right? If I plug in 0 for x, right, what do I end up getting from this?
Is that one like 0? So would it be 0?
So it would be 3 times the square root of 0, which is just 0, right? And then minus 6.
Okay, so it's negative 6.
Good. So that would be negative, right? So right off the bat, I know that this function, when we start at 0, is already negative. And I don't want to be integrating negative area, right? I want to integrate positive area because that's what this absolute value thing does. It's kind of, I'm trying to think, what's the example of this I want to think about? Yeah, it's okay. Let me show like an example of this. Let's say, for instance, I had the absolute value of x minus 3. Let's just say that from 0 to 6. Okay. One way to represent this function is I could represent this as what's called like a piecewise function, which means I could split it into 2 different functions that are happening at different points in time, right? So in this case, I could say, oh, this is the same thing as negative x plus 3, right? From 0 to 3. And then regular x minus 3 from 0 to 6. Sorry, from 3 to 6. This would be the equivalent of an absolute value function, is to split it into 2 different functions that have different domains, which just means that for different values of x, they're different functions. That's what a piecewise function is, right? Okay. Because, okay, this, right, would look something like, I'm trying to think of this. So x minus 3 would end up looking like this, right? This is what the function looks like. The absolute value of x minus 3. If you don't trust me, we can always do this on Desmos. Let's learn together on Desmos. Where's our graphing calculator? There we go. Let's see. ABS x minus 3. Well, absolute value is just a v, is what it is. Do you see how this is a v that pops up, right? Okay. That is the same thing as writing 2 different functions. Okay, so in reality, this right here, this is y is equal to negative x plus 3. But that's going from 0 to 3. Whereas this part of this part of the function, right? This is y is equal to x minus 3, but that's going from 3 to 6. Do you see how we did that? Do you see how I took a single absolute value function, but then I wrote it as 2 separate non-absolute value functions?
Mm-hmm.
Okay. And all I did was
from
Go on.
so from like 0 to 3 would be like the negative, but you just
Mhm.
converted it into quickly to like +3 negative x.
Yeah,
And
so
the other one it just stays.
stays the same, right? Yeah. So wherever it is positive, it stays the same. Wherever it is negative, I'm just going to multiply the whole thing by -1. Because that's basically what an absolute value function does. It says, oh, you're negative, I'm going to multiply you by a negative to make you positive. So I just figure out where is this function negative, 0 to 3, and then I multiply the whole thing by -1. So that's why that became -x plus 3, right? Because this is -x and then minus minus is plus.
Mhm.
Okay. Okay, we're gonna do the same thing here with the integral because we don't really have integration rules for absolute values. We just don't. Like they don't really exist. So what I need to do is I need to break this thing into two separate functions, similarly to how I did with the other one, and then we're gonna have different domains, different values of x that each one corresponds to. So right off the bat, I know that, okay, when x is equal to 0, this is already negative, right? So I'm already in the land of, like, I need to multiply everything by -1. But let's figure out where that stops happening, right? Where does this function stop being negative? One way to do that would be to just set it equal to 0, right? And that we know that's going to be our boundary point. So if I move this over, right, this becomes 6.
Right.
Good. And then, right, divide by 3. That becomes 2, right? And then square both sides. And so we just get x is equal to 4. Okay?
Well,
So 4 is the boundary point where our function goes from being negative to being positive.
Uh-huh.
So what I'm going to do...
Then they get cut like
Yeah?
in half, right?
It's
So
not...
like 0 to 4 and then 4 to 16.
Good, yeah, but that's not in half, right? That's cutting it in like a quarter, right? It's like a, 0 to 4 is a
Oh,
quarter.
my bad. Yeah.
Yeah, it's okay, it's okay.
Yeah.
So it's 0 to 4, but then I need to make everything here multiply by -1. So that's why this becomes -3 square root of x plus 6, right? All dx.
Well,
And then the function's cool after 4. It stays positive, so I can leave it how it is. So then I'm going to say, okay, from 4 to 16 of just what the regular function is. Dx. Does that make sense?
yeah.
Cool. All right, awesome. Okay, and then, okay, that's the hard part. That's the hardest part of this question. After that, this is all just doing regular integration, right? Do you know how to
Regular,
do...
yeah.
Yeah, you know how to do this as regular integrals. Yeah, exactly. So, let me just see if I remember what that is. It's -3 x to the 3/2, and then it's divided by 3/2, right? Plus 6x, and then this is all evaluated from 0 to 4, and then this is plus 3x to the 3/2 all over 3/2 minus 6x from 4 to 16. And then, yeah, plug stuff in, you get an answer, and that should be good. I assume you know how to do that. You don't need help with that part, do you?
Yeah. The part that I was missing was making it equal to 0 to find that.
Yeah, find that boundary point, yeah. So in this case, we were lucky because there's only one place that this function went from, for instance, from being like negative to positive, right? It only happened at one place. If this function was, I don't know, like x cubed or something, or some weird thing going on where it crosses a couple times, right? Then you need to figure out all the spots where it's doing that. And then anytime it's negative, make the whole function negative, and then anytime it's positive, just leave it how it is. But this one was pretty simple. I mean, square root of x is just going one direction. It's not gonna flip back and forth. Something like x cubed would, but like this one doesn't. Cool.
And when there's like three, I mean not 3 or 2 or switches.
Yeah, you just have
still
to
equal to 0.
Yes, you can still set the function equal to 0, right? And then let Let me try. Let me think of an example where that would happen. Oh, here's a classic one. Let's say they wanted you to integrate 0 to 2 pi of the absolute value of sine of x dx. Okay. So sine of x, right, looks something like this. Well, okay, let's make it like a little bit more fun. Let's do it like this. Okay, there we go. This would be like from 0 to 4 pi. In this case, right, there's multiple regions that this function drops below, right? So we could say, okay, sine of x is equal to 0. Solving for that, you know that happens at, pi over 2, 3 pi over 2, 5 pi over 2, yada, yada, yada. But you have to keep doing that as long as you're still within, like, the range of the integral, within the bounds. So for sine of x, if we go from 0 to 4 pi, there's actually 2 regions, right, where it's going to be negative. And that's going to be from pi over 2 to 3 pi over 2, and then from 5 pi over 2 to 6 pi over 2. Yeah. So in this case, we would have to break up this integral into technically 4 different integrals. I'd have to do this one and this one regularly, and then this one and this one with the negative. Falcon says, I remember these. I don't like these. Yeah. So yeah, setting it equal to 0, Josue, at least tells you the boundary of where it's either going from positive to negative, but then you need to figure out like which of the, between the boundaries is negative and which of the boundaries is positive. Which you could do by graphing, or you could do it by, just plugging in numbers, right? You could look at the function and be like, oh, cool. What is sine of pi? Because pi's in between these, and you'd see that that's negative. Wait, sine of pi is, wait. No, sorry. Ugh. I have this wrong, actually. 0. Sorry, no, this is... I screwed up my signs. Okay, sorry. Sine is not... So sine of x is 0 at 0 pi, 2 pi, and 3 pi. That's what it is. Sorry. Yeah. Pi. I'm having a Monday moment. 2 pi, 3 pi. That's what it is. I was confusing this with cosine for a second. Yeah. So yeah, in this case, right, 0 to pi is positive, pi to 2 pi is negative. If you plugged in, let's say, 1.5 pi, which is just 3 pi over 2, you would see that the function is negative there. And you're like, okay, cool. That's a region. I need to put a negative in front of the function before I do the integral. But yeah, set it equal to 0 so you can figure out where those crossing points are. And then you got to figure out in between the crossing points which regions are negative and which regions are positive.
Okay.
So do you want to eat my...
Cool. All right, nice. You're good, dude. All right, I know it's dinner time anyways. Good job, Jose. That's great, dude.
All right, thank you.
You're welcome, dude. Nice. It's a good question, actually. I like that one. Okay, cool. What were you saying, Noise? You wanted... Yeah, let me try that. You want... What, Symbolab? What's this website you guys use? I use Wolfram for everything. Maybe I'm old school. You guys use Symbolab? What the fuck is Symbolab?
I've been on that side as well. Never been on Wolfram though.
I don't like the... There's like too much stuff going on. So many animations and stuff. Let's integrate... what do you want to do? Square root of... x squared minus 4. Oh, it's kind of cool. Symbolab equals cheat. Okay. Does it do it? Simplify x squared. Use trig substitution. Okay. Oh, this is super ugly. Oh, this is so ugly. What? No, Noise. Why? Why would you do this? Ew. Yeah, this is gross, dude. See what Wolfram says. I'm curious. Yeah. Yeah, they do 2 secant of view, and then DX is 2 tangent. Yeah. Yeah, okay. Yeah, it's kind of the same thing. It's all good. Yeah. I would use hyperbolics. Yeah, so, yeah, I mean, yeah, hyperbolic substitution I think makes more sense in that case. Yeah, this was the stuff I was. Yeah, this is the image that's really useful. It's this stuff right here. Maybe I'm just weird then. No, Noise, you're unique, special. But yeah, these are the general the tricks for using trig sub in calculus. If you ever see stuff like this, use this so that this, and then yes, and then eventually this just becomes a cosine theta, and hopefully it pops out something nice. Yeah. They all work. They all work at some point. And then so the thing is, once you use this, then you might have to use, for instance, integration by parts, or you might have to use partial fractions or something. I don't know. Like, things start becoming more and more like a snowball effect of like trying to fix things to make them look like really nice integrals. But these are the good like starting point, like cheat sheet things. So here, I'll post this for you, Josue. There you go. That's the general guide that you sometimes want to use. Yeah, that's the fun part. Honestly, integrals are fun. It's kind of like a puzzle. It just can get really frustrating sometimes when you go down this rabbit hole. My favorite one is the integration by parts when it gets cyclical. Have you done that before? Like cyclical integration by parts? Where like you integrate by parts a couple times and then you get what the original thing was and then you just set it equal to itself. Yeah, I'm sure it is. Yeah. Yeah. Cyclical.
Is it time for my question?
Yes. Well, yeah. Well, oh, here, let me do Bob's real quick. Bob's been waiting for a bit. I haven't talked to Bob in a bit. Here, Bob, come on the stage. And then yes, Ethan, then I'll do yours. What's up, Bob?
Not much.
So wait, you got 100 on your calculus final?
Yeah.
Fuck yeah, dude.
The raw score was. Let's see what the raw score was.
It just had like a massive curve on it.
The raw score was 103 out of 130.
103 out of 130? That's pretty good. Yeah. It's like an 80 at
And
least,
then
right?
After the curve, it was 100.
Wow. Wow, dude. Look at that. Your first semester at college, dude. And what? You definitely got an A in the class, I'm guessing, right? You got 100 on the final.
Yeah.
Nice. Sick. And so, remember when we were talking about this, Bob, how, what was I saying? Because you were like kicking yourself that you didn't take AP calculus, like the test, right? The test out of it.
Yeah.
Right. Do you see how like college calculus is a lot more in depth, a lot more rigorous than like what you take on the AP exam?
Yeah, it is.
Yeah, it is. What's up, Ed?
Makes
What's
you
up?
think more.
It makes you think more. Yeah. So I think you made the right decision, like quote unquote retaking calculus in college, because you at least now have all the previous knowledge of taking AP calculus, but it allows you to go more in depth with what college calculus actually gets you into.
Yeah.
Nice. Okay, here, let's do this. This is a good question though. Did it help? Like, I know we went through a couple examples before your final. Did any of those like show up? Any of those weird examples we did?
Nothing as hard as that.
Nothing as hard as that. That's good. Okay.
Yeah.
Yeah, some of those questions you showed me were just like nightmare level hard, dude. I was like, what?
This one was probably the hardest so far. Actually,
Yeah.
I think it was
This
one of
is
the hardest.
is this related rates, I guess, right?
Yeah.
Yeah, we like related rates. I actually like related rates. Okay, let's see. 5 out of 10 pages, dude. Oh my god, dude. Yeah, I do not miss taking college exams. 10 pages of questions? Ew. Okay, taking the shape, inverted grid, blah, 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 blah. Okay, its height is 6. Good, you drew that correctly. And the length of the side is 3. Awesome. Water is poured at a rate of 2. At what rate is the height of the water rising when the height of the water is 4 meters? Hint, the volume of a pyramid whose square of side W and height of H is given by this. Oh, that's kind of nice. They gave you the equation like right off the bat like that?
Yeah.
Okay. So yeah, you have the right. Well, here, let me just like correct your work. I can just correct what you did wrong. So you did V is equal to that, and then you. Okay, so what I would do straight off the bat before I even start deriving things is I want everything to just be in terms of one variable, just to start with. Because what you're doing here is okay. But now you have things in terms of in W's. See, W is changing. This is the problem. W changes with time. As you add more liquid to this cone, W is still changing.
Yeah.
Yeah. See, W is constant. Yeah, W is not constant. W changes for sure. So this is where you have to do the what is it the like triangles thing, right? So if this is H and this is W and this is 6 and this is 3, right? That means 6 over 3 is the same thing as H over W, right? Okay. So now this just gets me H is equal to 2W. And what do we want? We want eventually the height of the water. Okay, so I really want to write this as W is equal to H over 2. Okay. Because now when I plug this into my volume equation, right? This is going to get that volume is equal to H to the third over 12. Yeah, it's W squared. So it's H squared over 4, and then it's times another H, which makes it H cubed, and then there's a 3 on the bottom, so it's good, right? So now this is a much easier integral to do, right? Now I just have dv dt is equal to 3H squared over 12 dH dt. Nice job, Norris. Good job. Yeah. Okay, and then we're solving for DHTT. They give us DVDT is what? 2? Yeah. Oh, man. Oh, this is simple, dude. This is like a 2-step question, dude. You're done at this point, right? 2 is equal to 3.
I couldn't figure out the W and H, I guess.
Yeah, okay. And this is DHTT. This is just done. This is easy. Oh, they gave you such a softball on this one, bro, dude. What? This is a softball question. What? So 8 over 4 squared is equal to DHDT.
So 4 or
1/2, just 1/2.
you do it 1/2.
Yeah, it should just be 1/2. Yeah. Yeah. Yeah, I see here. Yeah, you ended up doing like the quotient. Is this? No. This is a. Are you doing the quotient rule? Ew, no.
Yeah.
No, don't do the quotient rule here. First of all, you only need to do the quotient rule if there's a variable on the bottom that's being derived. If anything, this is just a product rule. Yeah, 3 is a constant. You don't need to do shit with 3. You can pull 3 out. If you wanted to do this using the product rule, this would have been 2W dW dt times H plus W squared dH dt, and then this would be all times 1/3. Is
that really equal to whatever I do?
That's equal to dV. Is it?
Because like there's 9 on the bottom and stuff for what I did.
Well, no, yeah, because you did the quotient rule and you like squared the bottom. You don't need to square the bottom because the bottom's not a variable at this point. Yeah, the bottom's just a constant. Yeah. Then the issue with this is now I have things in terms of dW dt and dH dt, and I'm not really solving for dWt, and this is dV dt is what this is. So yeah, number one rule when you're doing related rates, like make sure everything's just in terms of like the rate variables. So in this case, just dV dt and just dH dt. Fuck the dWt. You don't need it.
Yeah.
Cool. Awesome.
Is there more of this in Calc 2?
No. So Calc 2, you're doing integrals next, probably, right? Calc 2.
Yeah.
Yeah. So Calc 2 is going to be integrals. And then there's a lot of sequences, series, which I think you probably did a little bit in high school, right? Did you do sequences and series?
I don't think so.
No? Okay. Yeah.
think I went over one with me.
I think I did, yeah. So the big thing for Calc 2, the thing that, like, this is the motherfucker that screws everyone, is, like, proving convergence of, like, sequences and series. And let me see, I probably have a table of it. Sequences, series, calculus, tests. It's these. This is the big motherfucker that everyone has to learn.
It's hard.
This, yeah. Well, it's not necessarily that it's hard. It's again, it's a puzzle, and these are all the different ways you can solve the puzzle, and you have to figure out which way you want to use. So yeah, a lot of what Calc 2 is determining whether a series converges or diverges, and then it's like, does it conditionally converge or whatever, like, or absolutely converge, and it's all about using these different tests for things. That's going to be the meat of probably what your class is. And also, you haven't done volumes of revolutions yet,
That's
have you?
Calc AB.
Right, but yeah, you did that in high school, but you didn't do it in college yet, did you?
No.
Yeah, okay. So yeah, so you got all the volumes of revolutions, which is, right, the washers and disks method, and then you're going to have all this.
Yeah.
Yeah, sequences
Yeah.
and series, yeah. And then after this, if you have to take Calc 3, that's going to end up being all of the multivariable stuff. So,
No, I'm not doing that.
okay, you don't need to do it yet. No.
I go to
You're
linear
fine.
algebra after.
Linear algebra, yes. We like linear algebra. Linear algebra is dope. Yes,
Alright,
exactly.
thank you.
Yeah. Yeah, you're welcome, dude. Nice. Good job, Bob. Enjoy the break. Enjoy the holidays and stuff. You went back to San Francisco already? Yeah? You're not in LA anymore? Oh, we did. Linear algebra, my beloved. Yes, she is the beloved. Yes, we do love that. Nice. Good question from Bob. Okay, Ethan. Let's see. What's up? What was your question, Ethan?
I put it as a Java code.
Oh, Java code. You want to write some Java code? Okay.
Yeah, what if I try to say the code out entirely? Like, no, not you helping me.
Well, okay. So the best way for that to
Wanna see
happen,
it.
Ethan. Yeah. Well, let's not do that live on the stream because that's going to take like 30 minutes. Here's a good assignment. You said you're bored, right? You said you're bored at, it's day 1 of your Christmas break and you already don't know what to do with yourself, right? What if?
It's like, I really just around, which is honestly kind of weird.
Yeah, I know. Well, because school creates this like structure for you where you're like, oh, I have something to do. Like I have homework. I have to go to class. I got to go to, I don't know, lunch. I got to do this. And then you get home for the break and you're like, I don't know what to do with myself because I don't have a job anymore. I agree that you want to stay sharp with what's going on and not experience what's called learning loss. Learning loss happens when you don't go to school for a bit. It's actually shown to be real. I think it's like 20% over the summer. So if you want to have something to do, Ethan, how about you try to do this computer science program thing on your own, and then you bring me the code you got afterwards, and I can help you debug it on the stream. I feel like that would be a better use of the time.
What's the bug? What's
What
the bug?
Oh, what is debug? Oh, debug means you're going to write code, and maybe it'll work the first time. It usually doesn't. Like, code never works the first try. But then debugging is me going through the code and figuring out what is wrong and how you can fix it. That would be the best way. He's going to try and do Java, I think, Bob.
That's it.
Yeah. So yeah, so that's a great thing to do, Ethan. Yeah, why don't Ethan, you take that question. I'll still give you bond coins for it. But like, how about you try to write it on your own? And then I can go through and make sure whether it was correct or not.
All right.
Cool. Bob says, I'm going to try to relearn Python over the break. Yeah, Python's a great language. One of the most widely used programming languages in, the world, I guess, because it's relatively straightforward. What? What's up, Ethan?
I'm learning it.
Yeah, I know you're learning it too. Yeah. I mean, all languages are kind of the same, honestly. As long as you know how to code in one language, you can figure it out how to code in the other languages. It's just like it's a translation issue at some point. It's just knowing what the different syntax format stuff is. Like Python doesn't use brackets, I think. I think they use tab for everything. Right? Tab is how they demarcate like where blocks of code are, which is like super weird to me. I'm like, what? Tab? My Python code C GigaChad. Yeah, C is dope. I learned C++. C++ was the first language I learned on.
Wait, Dr.
What's up, dog?
What's the area of a rectangle?
The length times the width.
Wait.
Yeah, not too bad. Let's see. We did do that one. I have to go somewhere soon. Can you solve one or two of these and send me the screenshot? Let's see what this one is. I'm curious about this one. Let me try this one. Oh, I forgot that Jamarcus always takes like the highest resolution images that are like known to man. Yeah, it's gonna get. Dun dun dun. And then Teacup has a good question. Ooh, arc length. I like arc length. Show that the arc length of the asteroid x is proportional to A. How does that even work? What? One second, let me close this. This is mad. Here, let me pull this in. Oh, mainly type. Okay, so there it is. There it is. There it is. There you go. Okay, cool. All right, given q squared plus 1 over q squared is equal to 11, q cubed plus 1 over q cubed is 18. Find q plus 1 plus q. Okay, that's interesting. Here, let me. That one's like just too big. There we go. There we go. This is easier, more manageable to deal with. Okay. I wish this was like a sum of cubes. Well, I mean, this is kind of a sum of cubes is what it is. Oh, actually, whoa, is this just a sum of cubes question? Maybe it is. Okay, that'd be kind of cool. A cubed plus B cubed is equal to A plus B. Same, opposite. So it's A minus AB plus, oh, A squared. Right. This is it. I'm pretty sure. It's called like SOAP or something, right? Was that the thing? It was called SOAP. Yeah. Same, opposite, always positive. Yes, cool, great. Okay. Remember all the acronyms. Okay. So, in this case, right, A is equal to Q, and B is equal to 1 over Q. Okay. So this is going to be equal to Q plus 1 over Q. This is actually really cool. So here, watch this, watch this. Q cubed plus 1 over Q cubed is equal to that. And then that's going to be Q squared plus 1. Oh, wow. This is so cool. Actually, this is a really cool question, actually. This is Q squared minus 1. Right? Because Q times 1 over Q, good, plus 1 over Q squared. Okay. And I know all of that is equal to 18. Okay? And we're trying to get this, which is basically this part. So, in order to get this, I need to figure out what this is. And this is, let's see, that's, yeah, oh man, it's so close. It's so close. Okay. I like this. This is such a cool question, Jamarcus. Okay. This is Q squared plus 1 over Q squared, right? Which from here is just equal to 11. Okay. So now I have this times 11 minus 1, right, is equal to 18. So this is just equal to 10, right? So this is equal to 18 over 10. Or, yeah, it's just equal to 1.8. Cool. Wow. Dude, this was a very fun puzzle math question. Wow. Yeah. But so cool how you had to remember, again, something that I worked on with students on Friday, which was you had to remember what the sum of cubes are, right? Sum of cubes is equal to this, and it just so happens that this thing is what we're looking for, and that this thing ends up being this with a constant, with another number on it. Yeah, and the only way you can know that is just by, like, just, you know, trying it. Okay, wow, that's cool. I like that one. That's a very cool question. Wow, okay. I feel good about myself after that one. You know, like, sometimes I get... That's the first one of these questions that actually made sense to me. Thank you. I know, right? Yeah, I'm just like, usually I'm like, why the hell are we asking this question, dude? Yeah. Yeah, this one was cool. This actually, like, went over a relevant concept instead of, like, some of Jamarcus's other Russian math questions, which are just nightmare mode. Like, here, like, let's see what this other one is here. No, come on. Yeah, like this one. Like, compute 1 times 2 times 3 plus 2 times 3 times 4 plus... I mean, what's happening here? So what... This is like 3 factorial plus... That's 4 factorial over 1 factorial plus... I'm gonna guess 5 factorial over 2 factorial. ... Until eventually we get 22 factorial over 19 factorial, right? Yeah, but just like, why? Is there a pattern here? Like, I don't know. How am I supposed to calculate this? How am I supposed to do all the in-betweens? This is a mess. No. It seems right, yeah, but do I really want to go through and calculate the other 20 terms here? Or is there a pattern here maybe I'm not seeing? I don't know. Yeah, is there some pattern for, like, a factorial over b factorial? That's what Python's for, correct? Yes, but I don't think they get calculators on their questions, so no, you can't do this one. This one was good, actually. I did this one last time, but actually I did it wrong on the stream. So let me give myself a redemption arc here real quick, because yeah, I did this one wrong. Someone pointed it out to me later. I was like, point it out to me during the stream if I do something wrong. Like, I have you know, math brain fart moments all the time. You don't think that one's so bad? Oh, Ian, yeah, dude. If you know what this is, if you know, like, an easier way to do this, please, yeah, tell me. I would love to know. This one isn't too bad. This again is more difference of cubes, adding cubes and stuff. Oh, let's see. Yeah, so wait, this is the sum of what, from k equals 2. K minus 1? One sec. What's up, Ethan?
I did the code.
You already wrote all the code?
Yeah.
Oh, cool. Can you
Use another one as reference.
One sec. Let me go through this real quick, Ethan, then I'll get to that. One sec. Yeah, this is to what? To 20? Is it to 20? No, it's to 21. To 21, I think. Yes. Yeah. Yeah, but then what does this simplify to anything nice? Well, I guess, I mean, this is kind of nice, right? One sec. That's sum k equals 2 to 21. And then this is k squared minus 1 times k. Because this is a difference of squares. Oh, okay. Maybe not so bad. This is k cubed minus k. Okay. Which I can evaluate these things independently, right? So, the sum of cubes formula. Wait, is it a sum of cubes? Wait. Sum of squares. Sum of squares formula, I think, right? Oh, okay. I know what you're talking about. Yeah, and what is that? Like, do we know that? Sum. Is that a geometric series? Is that how that works? Wait. Sum of cubes. Yeah, but it's not. No, it's not called sum of cubes. It's a series, right? Series cubes formula. Yeah, this is it. Okay. Okay, it's it's equal to this. Yeah, okay. Yeah, but again, like, how are you supposed to remember that? I don't remember that. I just wish they wouldn't have it as like a where's this just Yeah, this is what I want. I just want this not blurry. Where's the not blurry version of this? Yeah, this is it. Okay. This is what it is. Uh-huh. Okay, so from this, I always forget the off by 1 or something on this, right? This is where my computer science brain wants to start everything at 0 as an index, but it's not. Yeah, and then what's the other one though? Is there a formula for the sum of not cubes, right? Yeah, this is it. This is what I want to know. Yeah, here we go. This is it. These are all the formulas. One sec. Yeah, these are them. These are what we need. So, and D is the... What is D in this case again, sorry? D's the difference, I think. So it's series. Okay. So S20, and then you just subtract the first two ones. So S21 in this case is 21 over 2 times 2. And the first one in this case is 1, I guess, yeah. And then it's plus 20 times 1. Oh, it's the average of them, isn't it? Don't you take the first one and you take the first one and the last one and you average the two and then you multiply it? I think that's if it's an arithmetic series. I think that's how that works. Huh. Yeah, because that would make sense. That's the 21 over 2. And then it's 2 times the first one plus n minus 1 times... Dude, what is... Okay. I need to see what, like, A and D and all these things are. There we go. Thank you. This is what I want. Okay. Yes, it's the average. It's the average. It's the first term, the last term, and then it's the number of terms. Okay, yeah. Okay. Yeah, I just have to double check myself. This is... Dude, fuck this one. This one looks terrible. Like, what? That's god awful. That's what I want. Okay. 2 to 21 means you're adding 19 terms, right? Or 20 terms, right? Yes, 20 terms, 20 terms, 20 terms. Yeah. So this is going to be 20 times, and what, that's 2 plus 21 all over 2. I think that's right. Yeah, first term, last term, divided by 2, number of terms. 20. Yeah, there's 20 terms. And then this one is going to be so this is going to be S of 21 minus S of S of 1. So an S of 21 is going to be 21 squared, 21 plus 1 squared all over 4 minus 1 squared, 2 squared all over 4. Okay, cool. That makes sense, yeah. Because, yeah, you're not adding... Okay. So then, what's that? That's 21 squared, 22 squared over 4 minus 1 minus 20 times 23 over 2. Okay. Cool. Yeah, okay. Yeah, that's how that one works. Okay, nice, Jamarcus. That's a good one. Another cool one. Yes, I can post it. Yeah, screenshot you need help for it. Yeah, right there. There's that one. Yeah, let me get the other trig sub one you had. You need. Was it this one you needed help with, Josue? Yeah, cool. I got you. There you go. There's that. Don't worry, Tico. I'll get you. I'll get you, dude. Yeah. All right. Let's see. Ethan, what's up? You posted some code?
Yeah, I posted it in the office hours.
Good. I got you. What do you guys use? JDoodle? What do you guys? What web thing do you guys use for Java code again?
Online GDB, not JDoodle.
Online JDB. Oh.
GDB.
Oh, GDB. Okay, cool. All right, cool. Let's select Java. Let's do this. Okay, cool. What was the question? It just needs to calculate the length of a rectangle.
Yeah.
Let's see if it runs. Enter the length of the rectangle. I don't know. 4. Enter the width. 5. Area is 20. Wow. Yeah, that works. Good job.
Mm-hmm.
I didn't have to really debug this at all. Like, you know, I don't like scanner. Don't do this.
Look, Dr. Go, I really can't help it. That's what I've learned. I can't do anything else.
I'm not gonna.
Are you serious?
Yes, dude. This is what it should be.
What?
Don't call your scanner a scanner. Thank you. Okay, great.
But
Now it's
don't do
fixed.
anything.
It doesn't do anything, Ethan. It's good coding practice is what it is. It's better coding practice to not call your object the same name as the class.
Okay, then.
I'm just trying to like help you out like in the real world. If you start actually like doing code, like you don't want to do that.
Well, the next stream, guess what? I'll just try that. I'll try that one.
Yes, Jamarcus, you do get a point. I did give you a point. Did I not give you a point, Ethan? Jamarcus, did I not? Oh, Jamarcus, I'll get it to you. Yeah, my bad. That's kind of a pain in the ass of a question, though, Jamarcus, to have to do that other one. But yeah, good job here, Ethan. I feel like you should
I
like
mean, you should try to.
you should try to like make like a game maybe with Java or something. I mean, this is simple. Like you know how to do this.
Nope,
This is
nope.
very easy.
No, this is not good. Actually, I do have a code from a game from a very long time ago.
Okay.
I mean, I have the code right now if I can try to find it.
Yeah, go find it.
Right. Yeah,
Let me
I
help.
finally
Let
found
me
it.
help
So
out.
see,
Let me help. Dude, what's going on here, dude? What
see,
are you?
I
What am
have
I drawing here?
that's what I have the thing here. I have the code.
Okay.
Hold on.
Where's Teacup? Teacup can't talk because
See,
he's.
I have it.
Did you
That's
copy it?
right there.
Did you copy it? I didn't see it.
Yeah.
Oh wow. Ah, okay. Yeah, 1 second. Let me pull that one in. Bum 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 bum. What's all this? Okay. Oh, did I help you with this one? Did I help you write this code?
No, you never did.
Oh, I never did? Okay.
I saw it. Like I said, it was from a very long time ago.
Okay. Well, let's see if this thing runs. I'm just curious. Yes, input validation. Yes.
These are. See, the
what's-
thing is,
Oh. Oh, I like this. This is fun. Oh, man. Oh, no. Numbers. Oh, I screwed up. Numbers higher. Oh, no, no, no. No, dude. Oh, I got one guess left. I think it's 44. I win! Wow.
see, it sounds like a guess a number.
Yeah, this is cool, man. This is a fun game. This is an example of like code actually being interesting because this is a fun piece of code. Okay.
Yeah.
Did you write all this yourself? Do you understand how this is
No,
decently complex code?
I don't know any of it.
Okay. Human binary search algorithm. Yeah, literally. Yeah. Yeah, you are so right. I just did a binary search, yeah. You know what I used to love? Well, I love all the sorting algorithms they have in like CS, right? Isn't there like the bubble sort? Bubble sort was my favorite. This would be cool,
see,
Ethan. Ethan, this would be cool to go through to like explain to you why the code does what it does. Because it's a cool game. It's a very cool game. I like it. It's a good idea.
I still have this thing you hate.
Yeah, I know. You still have scanner scan. It's okay. I see it.
Mm.
It's okay. It works. I like the videos comparing the
Yeah,
speed of
see,
the sorting algorithms. Yeah, they're cool.
Honestly, I really don't know if I'll ever be ready for exams at this point.
Yeah, you will, dude. What? You got tons of time. We got weeks. Weeks and
Yeah.
weeks.
I'm already worried about this.
Well, did your teacher give you any sort of like test review or anything?
No, they haven't given us. They haven't even given us an exam outline.
And when are your tests? Like right when you get back?
No, not right when. It's
Oh, okay.
like it starts on a Friday in that same week.
Oh, okay. So you at least got a week.
It's almost like an extra week, but Friday's when
Yeah,
the
you get like a
exam
week.
starts.
You get a week. You're good, dude.
Please, I really do need help.
Okay. Well then, yeah, we're here to help you, dude. That's what we do here on the stream. We help you out.
I need you to give me practice questions, something like that for help.
Oh, give you
For me to
practice
practice.
questions?
Yeah.
Sure. Can you send me what the syllabus is for your classes so I know what type of questions to give you?
Oh, what you mean the syllabus?
So whenever you start a class, your teacher should have a piece of paper that outlines what they're going to go over in the class. This is called a syllabus. It shows
Oh.
like what topics are going to be covered and usually says, when the tests are, what the grading policy is or something. Yeah. See if you can find the syllabus for a class that you're concerned with, and then I can figure out a way to like help you.
And it's like I think I want to see four of the main things I've done.
Okay.
Like how do you say it? There were four main things I was discussing during this entire class. Like we went on some little small topics. There
Mm-hmm.
was stuff like you know loops, right? You know loops in Java.
Yes.
We were taught if statements, for loops, and while loops.
That's good. Yeah, those are all very important things. Yeah, do while,
Yeah,
for
and
loops.
the thing
Dude, this
is
is
that
super. Yeah, what's up?
the so the thing I noticed is that they told us how to convert from for loops to while loops.
Yeah, they're similar. It's just like usually just off by one.
Yeah, it's like you gotta do. It's like I had to do that. Next thing that I did was just algorithms and flowcharts. Like what
Mm-hmm.
those were about. That was pretty simple for me. The simplest topic of them all.
Mm-hmm.
And then the last part that I know of that's mainly discussed is what I just did with you, functions.
Yeah, functions are good. Oh man, dude,
And there's
Noise.
one
This
that
video is so dope. Noise. What? I love this video. This is a computer science thing, Ethan. By the way, this is showing how like different algorithms in computer science, which use like for loops and while loops and whatnot, end up sorting data. Dude, this is so cool. The heap sort? Oh my god. What is going on here? I don't even know what a heap sort is. There's sound? Oh god. Oh, I didn't even know there was sound on this. What? Dude, they would call this the Radix sort LSD, dude. What is even going on here, dude? What are some of these sorting algorithms are, dude, wild. Oh man, this is super cool. I like this. Yeah, very very cool find there, Noise. Here, let me help Teacup out because Teacup's been sick. Okay, show the arc length of the asteroid. X to the 2/3, Y to 2/3 is equal to A to 2/3 for A is greater than 0 is proportional to A. Okay. The arc length. First we need. I don't know arc length. Yeah, arc length isn't that bad. I think arc length is oh, what is it? Is it the integral from like 0 to something, and it's like square root of it's like dy dx square, or it's like df. It's like df dx squared plus df dy squared. I think that's what this is. No, it's not a form. It's an integral, is what it is. No, it's an integral. It has to do with you're integrating the slope. Is what's up? What's up, dude? What's up, Gooder?
You won't believe what I'm on, bro.
You're on Fortnite, probably.
Oh yeah. How did you know?
How did you know? How did you know?
Yeah, I'm still grinding. Totally. I just cracked a whole new sword.
That's dope. One sec. I need like a visualization. Was it integral
So
for arc length?
I'm probably gonna see if tonight we can level up the village to level 5.
Okay.
And what's required for that? 15 knot trot, 20 planks, and 15 marbles.
Oh, we
So
have
I actually
plenty of
used
marble.
some of
Got
the
plenty of
knot trot.
marble. Got plenty of marble.
So actually, some of the knot trot that I had to use to craft a new sword because of my durability is running out on my other one.
Uh-huh.
And I'm planning to see if I can clear out that cave that we have near us so we can use it as a base
Mm-hmm.
instead of having to use the houses.
I
But we
see.
can't move the village because then we'll lose our level. That's the problem.
Oh, but it's too far away?
Yeah.
Oh, okay. Oh,
But we can use it as a secondary base so when we go there, we have still some of our stuff there.
okay. Okay. I'm down. Let me see here. Let me finish this question up. Let me finish this last question with Teacup, and then I should have some time for some Fortnite. What is this? Yes. This is how you do arc length. Yeah, and really what you're doing is you're taking like these infinitesimal, like small parts of like delta S, and you're adding them all up. Where delta S, right, is this, right? This comes down to the Pythagorean theorem, right? ds squared is equal to dx squared plus dy squared. Which then, yeah, if it's as a function of t, you can then parameterize it. This is parameterizing it because this is the slope, is what this is. Oh yeah, this is cool. Okay, so I don't even remember how we do this. Let me just take some derivatives. Usually just taking some derivatives like fixes something at some point. So, what is this? This is going to be 2/3 x to the negative 1/3 dx plus 2/3 y to the negative 1/3 dy is equal to 2/3 a to the negative 1/3 dA. Bum 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 bum. First of all, do they mean is asteroid like a thing? I know what asteroid is. What's an asteroid? Oh, asteroid is a thing. Ooh, look at this noise. This is pretty cool. This is what an asteroid is. It's a roulette curve with 4 cusps. Okay. It's the location, it is the locus of a point on a circle as it rolls inside a fixed circle with 4 times the radius. Yeah, look at this. Oh, that's cool. Okay. And then we have some parametric equations. Yes, cool. How do I get the arc length of this thing? Mm-hmm. Yup. Oh, fascinating. Oh, that is so cool. Yeah. Yeah, so this is what I was talking about, like, for arc length. Yeah, this is very cool. Very cool. This is a very cool question. So remember, yeah, I said it was something like this, right? Right, yes, which is this. So, and is it 4 times it? Oh, because they're doing the arc length of one of these asteroids. Yeah, they're doing this. Here, one sec. This is what they're doing. This is cool. So they're just doing the arc length from 0 to pi over 2, and then they're multiplying it by 4 because you have 4 regions that this happens in. And then yes, yeah, the integral from it's from like t0 to t1, and it's a square root of, we say, like dx dt squared plus dy dt squared, and then this is all dt, where t is your parameterization. So they tell us that the asteroid is this, right? X to the, so actually I didn't need to take derivatives. I just needed to be smart and just see what the parameterization was. Plus a to the 2/3 is equal to a to the 2/3. Okay, so this is cool. Because what I can say is I can say, okay, let's let x equal to cosine cubed of theta, and y is equal to sine cubed of theta, okay? Then, so something cubed to the 2/3, this is where you have to remember your exponent rules, right? Exponent to an exponent, these things cancel out. this is just going to become cosine squared of theta. And then the same thing for this. This, so sine cubed of theta to the 2/3 is going to become sine squared of theta, right? Very cool. So then this plus this has to technically equal 1. But it's a to the 2/3. Okay. So I think what happens is, yeah, you end up putting an a. And do you put an a here? One sec. Yeah, you do. You do just put an a. Okay, because then this is a to the 2/3, a to the 2/3, right? So then this plus this is a to the 2/3 cosine squared of theta plus a to the 2/3 sine squared of theta. That would be equal to 1. No, not right, nope, not yet, nope, no. Close, no cigar. Oh no, I think that's right. Wait. A. This is a to the 2/3. A to the 2/3. So that's a to the 2/3. Cosine squared theta plus sine squared theta. And then this whole thing is equal to 1. So yeah, good. That just equals a to the 2/3. Aha! Okay. Cool, which is what this was. Okay, awesome. Okay, so yeah. So the parameterization is, okay, and that's what they had here, right? Is this is A, this is A. Okay. So then they want to show that the arc length is of the asteroid is proportional to A. Okay, so then we just have to do this integral. So this is going to be the integral from 0 to pi over 2 times 4. And then it's the square root of the derivative of x with respect to theta, which, okay, in this case, that's, and then it's squared. So it's 3a cosine squared theta, and then that's going to be derivative sine is sine of theta. Technically negative, but whatever, it's squared. Interesting, okay. And then it's plus 3a sine squared theta cosine theta squared. Okay. And then this is all d theta. What's up, Unaccessible? I know, we're doing a little bit... this is complicated, like, calculus. It's okay. Let's see. Does this come out to be something nice? I hope it does. Okay. I see a 3a in both things that's being squared, and it's inside a square root, so I can just pull that out. I'm going to pull that out. And then I'm left with cosine to the 4th theta sine squared theta plus sine to the 4th theta cosine squared theta. D theta. Oh, man. Nothing nice yet. Oh, okay. Whoa. I think I see something. I think I see it. It looks so easy, even I could do it. Not what the... Yeah, no, okay. Okay, I can pull a cosine squared out of this one. This is cosine squared theta times cosine squared theta sine squared theta. And then this is... Okay, this is cute. This is cool. This is sine squared theta times sine squared theta cosine squared theta. Okay, cool. See how this is the same thing? Now I can factor this. Or I can pull this out. So now this is... cosine squared theta plus sine squared theta times cosine squared theta sine squared theta. Cosine squared plus sine squared theta is just 1. Goodbye. And then we got the square root of cosine squared sine squared, which is just cosine sine. Okay, so now we're at 4a integral from 0. Oh, sorry. It's really 12a. Integral from 0 to pi over 2. And then it's just cosine theta, sine theta, d theta. Last thing to do here is u sub. Say u is equal to sine theta. So du is equal to cosine theta d theta. So this is just 12a integral from 0 to pi over 2.
This question is taking longer than my mom leaving me.
So then this is u du, which is just going to be u squared over 2. So that's going to be sine squared over 2. So sine squared theta over 2 from 0 to pi over 2, which is... So that goes away. So it's just 1. Oh, so it's just 12a times 1/2. It's just equal to 6a. Cool. Awesome. Done. Nice.
Look at the screen.
What do you got?
See that?
What do you got? Is that our level on our Fortnite village? Upgrade the village? You just upgraded to level 5, dude? Wow.
So now we can have more people here.
Okay.
To get back to what I mean.
Let's get some more people in it. I'll see you on
So
Wednesday.
now
Hoping
we have
I
a
hope you feel better
build-
too, Teacup.
We have a new building now. So let me just go to it. Look how big this. Oh my gosh.
Big house. What's up, Inaccessible?
Yo,
I
big
just
house.
wanted to say GG. I just want to say GG. Let's go. All right.
GG, GG, dude.
GG.
This is kind of a complicated question to do, honestly, dude. This one was. Put the solution to the differential equation in vectors channel if you want to look. As a sick. Oh, does it? One second, let me find it. Oh man, there was a lot.
This is obviously so
I got a lot.
easy. I could
Just spot.
obviously do this. Yep.
You can speed run. You can do a speed run on it.
Oh.
Yeah, I don't think so. I don't think so, dude. I don't think so. Dude, where's my clear my clipboard? Jesus.
I really gotta learn balance. I'm not gonna lie.
You don't know bounds? You don't know how to do? You know how bounds work?
No, is it like
Oh, bounds are just like where you integrate things from. Not that bad.
What the heck?
All right. Justin, can you chill for a second, dog? Please. Thank you.
For that to go.
What's up, Ethan?
You wanna know what? You remember how I talked about my fourth Java test, right?
Your fourth job? What? Or your Java test? Sorry.
Yeah. You remember what I was saying about fourth Java test?
Yes.
So they were basically they had the last section which was like writing out a code, and they told us to do something like I can't remember how it was, but it's like we put the numbers in. It's like we don't let the user put in the numbers. We just have 3 numbers there automatically or something.
Okay.
I wonder how you do that because it's easy for me for letting the user do it, but when you put it in, it's kind of different.
No, you just manually set the variables to something. That's all you do. You just set them at the beginning.
At least show me how to do that.
Yeah, dude, it's super easy. Like what? Like for instance, in this code here,
The rectangle. Maybe do the rectangle one.
the rectangle one. Oh, yeah. Where did I have that?
The calculate area one. Actually, do Control Z. Do Control Z on that.
No, it's yeah. I don't have it. It's not. It's not still in my thing. This is it.
All right.
Okay.
Well, go
Like this. Yeah. Well, in
Mhm.
this case, instead of having them enter it in what it is, you just do this. You say, "Oh, the length is 12, and the width is 4," and now it doesn't say. Now it doesn't matter what they say. It's just gonna do it. You see how it's just gonna do the numbers with 12 and 4? Oh well. Sorry, I gotta put semicolons on this.
Also, you know, this just reminded me. Hold on.
Yeah. See, it'll just say the area is 48. That's what it does.
Oh yeah. So I also wanted to say something. That semicolon reminded me of what I wanted to say.
All right, what's up?
So you remember that one time with the little boy who started to hit on my code?
Yeah, the kid that hated your code. Yeah, what about it?
You remember those semicolons you forgot?
Yeah.
The thing is that while I was writing out the code, I forgot to put a semicolon in the import Java that uses without scanner.
Oh,
The
okay,
first
and that's
time.
why I did. That's why I didn't go.
No, I'm not done there. The thing is that when he discovered it, I decided to remove it, and when I ran the code, it still did it perfect. Just showed the error.
Okay.
So you mean to tell me that? So you mean to tell me that this man does not miss any code without semicolons?
No, people
That's
always mess
ridiculous.
up code. This is very cool, Noise. By the way, Noise. Yeah, this is a dope question. So, Noise, this is differential equations, but like here, this is you doing. It's like the inverse of the product rule, right? This is an inverse product rule that you do for this. I remember I taught DiffyQ like years ago, and so I remember some of these tricks, but like I kind of forget. But yeah, I think yeah, what you do is you create like a product rule, and then you integrate the product rule, and then here, yeah, this is a classic cyclical integration by parts question, which is very cool. Because what ends up happening is as you integrate by parts, you see that one of the integrals you're looking for is the same integral you started with. So then you can just move that over. And then yeah, oh wow, this is super cool. So then what does that get you? That gets you this. Oh, and then you set boundary conditions. Okay, cool. Very cool. Yeah, no, this is I'll give you a bond coin anyways. This is a dope question. I like this one. Super cool. Okay. Yeah, no, this is cool. Yeah, I have to remember, dude, I made like a massive cheat sheet at some point when I was teaching DiffyQ, because there's all these different techniques for solving different ODEs depending on like what it looks like the form it's in. And I remember this being one of the more unique tricks, the inverse product rule. Or that's you're integrating a derivative, a product rule derivative thing. Yeah. Yeah, particularly shoes and pretty pretty. Okay, cool. All right, thank you everyone for coming to office hours. Had a fun time learning with all you guys.
Yeah, guys. Thank you for coming.
Big thanks to all our subscribers. Thank you, Sensation Black, Sam, Penn Center. You guys are awesome. All of our Discord Nitro server boosters, great. I will do one more stream this week because it's the holidays. I'll do one more on Wednesday. So Wednesday will be the last stream until 2023 when the new year starts. 2024, sorry. Yeah, I need a break, Ethan. I need a break. I need a break, Ethan. I've been streaming. I've been streaming almost like every other day for the last year. Like, yeah, it was under my what was it? My Twitch, whatever, like the summary or something. Anyone see that? Twitch summary. Twitch summary. You know where they're like, where was it? Fuck, I don't know. One sec.
Yeah, Noise. I hate Desmos. It's like it's so hard to navigate.
One sec. Let me find it. Where's my like? Check
Guys,
the rest of you. Check your year out or something.
Guys, I'm having two concerts. One, I'm playing a solo. I'm doing a duet with my band teacher. I probably told you guys.
That's cool.
But the other one is like classical. Would I get two bond coins? There's still one if I post them because one's on Thursday and one's on Friday.
I think you can get one per week. So just post them on 2 different weeks. It's okay.
Yeah, I'm gonna do that.
Yeah, do that, dude. Do it up. Dude, where is it, dude? Where's like your Twitch creator wrapped or something? Twitch. You know, like Spotify does this, where they say like, oh, well, here's all the music you watched or something. Where's my Twitch recap? Yeah. Okay. Where is it? What is in my? Where the fuck do I get it? Oh man. Hype train. Okay, but where is it? This is like not helpful. Oh, here we go. Okay, awesome, cool. Yeah, here's my Twitch recap. Let's see for the channel. 1.6 thousand hours, 174 streams. So that's almost a stream
half.
every day for half the. That's almost a stream every single other day for this year.
That's almost a full school year.
Yeah. So yeah, Ethan,
Wow.
my top stream got 19 viewers. That's pretty cool. You guys have sent a lot of chats. That's awesome too. And top categories, yeah. Apparently we're the top 10% in science and tech. I think that's pretty cool.
Top 10%. Top 10%.
I don't know what it means by top 10%. Top 10% by what? Like I
You're
don't know,
top 10% in the like.
y'all have spent a lot of channel points too. Look at all the channel points have been spent. Wow.
You know, I should spend a channel point to get like 60,000 bond coins for real.
That's pretty cool. We had 260 new followers, 50 new subs, 9 new gifted subscriptions. We did 105 raids. Oh, we got raided 9 times. That was cool.
Yeah,
Our
really?
loudest fan, so Shifter is apparently one of our loudest. Shifter, shout out to you, dude.
Let's go Shifter.
Sensation, Nick. This is Grim, Teacup, Pen Center, Noise, Habibs, and Ethan. You're there. That's cool.
I'm at the edge.
Yeah. Don't forget to stream your recap. Be a part of it with a chance to. Okay, by turning your recap into a stream. Okay. Well, here you are, Twitch. This is my recap stream. Anyways, yeah. So my last stream of the year will be on Wednesday. I'll do it for you guys. I'll do one last one, and then take a break
And when
until
you
the next
back?
year starts. 2024. I'll be back when 2024
What-
starts.
What day?
I don't know yet. I'll find out. I'll figure it out. But, most of y'all are done with school. I need a break, honestly. I need to figure out what we're doing next with the stream and, everything else in life. So, yeah, give Dr. Gold some time to figure that out. That's what I gotta do.
So Dr. Go, I also realized something like a long time ago.
What's up?
So, do you remember which day was my birthday?
No. What day's your
That's it.
birthday?
It's March the 4th.
March 4th.
Yes.
That's cool. March 4th is
Oh,
dope.
So I looked into next year, and apparently March the 4th is literally on a Monday.
Oh, okay. So we'll probably be streaming. Probably streaming on your birthday. That'd be fun.
Again, just like last year, yeah.
We can do a birthday stream. That'd be cool.
I know birthday stream. The
Birthday
In
stream.
order for it to be a birthday,
Wait, I have a question.
in order to be a
What's up? What's your question, Accessible? What's up, dude?
No, you guys go first. You guys go first. I can switch this up. What?
Okay.
Hey.
Okay. All right. Again, thank you everyone for coming. If you want to keep hanging out, we're gonna play some Fortnite or something in the actual gaming stream. So if you want to come chill with us there, please do. If you're in the Twitch, don't worry, I got you. We're gonna raid. We're gonna go right over. You can come say hi. Oh, I got all these other people now streaming. Ian Stuckey streaming. Who's BeginBot? Who's this?
Who's
Do I follow
Begin?
these
It's
people?
probably
I
a
don't
bot.
know.
It's probably a bot. It's probably a bot. for real.
Yeah. You know what? Probably something I will start doing. Actually, I'm gonna just start raiding the other education streams when I do this stuff. So maybe I won't like raid the gaming stream all the time, but you guys can come play games if you want.
Guys, guess what? September 11th is on the Wednesday, so I can come do a birthday stream with you guys too.
Wow, dude. Love it, birthday stream. Okay,
But
but yeah,
in order, isn't
what's up?
so look, isn't it in order for a birthday stream to happen? Doesn't the person have to be streaming and not someone streaming for them?
I could be streaming for your birthday. It could be a birthday present stream for you or something, right? That could be a thing.
Birthday present stream. You get 100